Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn capacitors in series and parallel. You know that capacitor is used to store electrical energy. We can combine several capacitors of capacitance C1, C2 up to Cn to obtain a system of some effective capacitance. There are two possibilities. One is capacitor in series, another one is capacitor in parallel. Let us see one by one.
When the capacitors are connected
one after another, they are said to be in series. Each capacitor will store some amount of electrical charge on its plates regardless of its capacitance. This is because the charge stored by the plate of any one of the capacitor must have come from the plates of the adjacent capacitor. For example, consider C1, C2, C3 capacitors are connected in series with the battery of voltage V. Here, when the battery is connected to the capacitor in series, the charge minus Q are transferred from the negative terminal of the battery to the right side plate of the C3 capacitor. So this is my C3 capacitor, this is right side plate, this is left side plate. So here I have negative charge. Know that left side of the C3 plate is uncharged. Uncharged means it has equal number of positive and negative charges. Here I have negative charge. Due to electrostatic induction, positive charges are induced on the left side plate of C3 capacitor and the negative charges repelled by these charges. So it arranged on the right side plate of the C2 capacitor. Again, due to electrostatic induction, positive charges are induced here, negative charges are pushed to right side plate of the C1 capacitor. Here also, due to electrostatic induction, positive charges are induced on the left side of the C1 capacitor and the negative charges are transferred to the positive terminal of the battery. Each capacitors store equal amount of charges, say Q. So the voltage drop across each capacitor will be different depending upon the individual values of capacitance. So V1, V2, V3 are the corresponding voltage across the capacitor C1, C2, C3 respectively. Here the total voltage across each capacitor must be equal to the voltage of the battery. That is, V is equal to V1 plus V2 plus V3. This is our equation 1. You know the formula, Q is equal to CV. This is the general formula. From this formula, I want to calculate V. V means Q by C. Here, Q is same, Q divided by C1 plus Q divided by C2 plus Q divided by C3. Take Q outside into 1 by C1 plus 1 by C2 plus 1 by C3. This is our V. Here, if three capacitor C1, C2, C3 in series are considered to form an equivalent single capacitance CS, means this formula can be written as V is equal to Q by CS. So this is our equation 2 and this is our equation 3. Compare equation 2 and 3. So what is your conclusion? 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula for capacitors in series connection. And what is your conclusion? The inverse of equivalent capacitor. What is the CS? CS is nothing but equivalent capacitor. The inverse of equivalent capacitance is equal to the sum of inverse of individual capacitance. Another important point is CS is always less than the smallest individual capacitance. What is the meaning? See, I have three different capacitance value. Say C1 is equal to 10 microfarad, C2 is equal to 20 microfarad and C3 is equal to 30 microfarad. Means CS is less than 10 microfarad, which means CS is always less than the smallest individual capacitance. Here which one is smallest? 10 microfarad is smallest. So CS is always less than the smallest individual capacitance. Why do we use capacitor in series connection? You know that CS is always less than the smallest individual capacitance. So if you want to reduce the total or equivalent capacitance values, means you can use capacitors in series connection. Next one is capacitor in parallel.
Consider three capacitors of capacitance C1, C2, C3 connected in parallel with a battery of voltage V. Here each capacitor is connected directly to the voltage source. So voltage across each capacitor is equal to the battery's voltage V. That is V is equal to V1 equal to V2 equal to V3. However, the amount of charge stored at each capacitor is not the same. Depends on the capacitance of each capacitor. Let the charge stored in the three capacitors be Q1, Q2, Q3 respectively. According to the law of conservation of total charge, the sum of three charges is equal to the charge Q transferred by the battery. So Q is equal to Q1 plus Q2 plus Q3. This is our equation 1. We know that Q is equal to C into V. Here V is same, C is different. So C1V plus C2V plus C3V. V is common, take it outside. V into C1 plus C2 plus C3. This is our Q. Say equation number 2. If three capacitors are considered to form a single capacitance Cp which stores the total charge Q, Cp is equal to sum of individual capacitance, that is Q is equal to Vcp. This is my equation 3. Compare equation 2 and 3. So Cp is equal to C1 plus C2 plus C3. What is your conclusion? Cp is always greater than the largest individual capacitance. For example, C1 is equal to 10 microfarad, C2 is equal to 20 microfarad and C3 is equal to 30 microfarad, means Cp is greater than 30 microfarad. Another important point is, in a parallel connection, area of each capacitance adds to give more effective area such that total capacitance increases. Why do we use capacitor in parallel connection? When the capacitors are connected in parallel, the total capacitance value is increased. That is why we are using parallel connection. In this class, we discussed about capacitors in series and capacitor in parallel connection. If it is series, means 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. And Cs is always less than the smallest individual capacitance. If it is parallel connection means Cp is equal to C1 plus C2 plus C3. Here Cp is always greater than the largest individual capacitance. I hope this video is useful to you. If you like my video, please share and subscribe my video.